Good morning. Hope everybody's okay today. We're having a great day already. Let's review a little bit of what we have already learned. So, with some questions. What kind of celestial body is our sun? It's a star. Why would you classify it that way? Because it's very hot, it's made of gas, mostly hydrogen and helium, and it constantly gives off vast amounts of heat and light. So, how would you compare and contrast our sun with other stars? Well, our sun is a medium sized, middle aged yellow star. Most stars are bigger, but some are smaller. Many stars are hotter, but others are not as hot as the sun. Many stars are different colors. Our sun is brighter than some stars and less bright than others. Some stars are younger, some are older. And our sun looks bigger and brighter than other stars because it's so much closer to us than other stars. Like our sun, most stars are part of our galaxy. How do the sun and other stars produce constant heat and light? Well, the atoms of hydrogen in the star fuse together to form helium. This fusion releases vast amounts of energy in the form of heat and light. This is a continuous process. In our last Learn Aloud or Read Aloud, we learned, Learn Aloud's not a bad term for it. We learned that even though all stars look like they are the same distance away, they're not. And what do scientists use to measure the astronomical distance between stars and other celestial bodies? It's called a light year. So measuring distance between stars is a light year. And how far is a light year? 1 light year is the distance light travels in 1 year. It's about 6 trillion miles. What's the Milky Way? It's a giant spiral galaxy of which our solar system is a part. And how did the Milky Way get its name? Well, the ancient Greeks and Romans thought it looked sort of like a milky band in the sky. What is a galaxy? A galaxy is a very large collection or cluster of gas, dust, and stars separated from other stars by a lot of space. There are billions of galaxies in space. What's the name of the closest spiral galaxy to us? The Andromeda Galaxy. What's a spiral shape? Here's an example of a couple spiral shapes. Well, it includes certain well, it is a center with arms extending and twirling, swirling around the edge. You've seen it in seashells. You've seen it in a spiral staircase. You've seen it in a metal spring or a snail shell. Those are all spirals, sort of has a central hub around which there are curved arms. What words or phrases would you use to describe the universe? Gigantic, astronomical, filled with stars. Okay. And do you think scientists could measure the entire universe? Why or why not? We have not been able to yet. The idea that the universe is so vast and it's larger than anything we can imagine or currently measure sort of makes us wonder. We may be able to at some point. At this point, not yet. Maybe you guys will do that. Please grow up and design instruments that can measure the extent. And when you do that, please call me up and say, oh, I've done it. I have designed a machine, an instrument that can measure you the entire universe. I'd be really interested to know that. Today we're going to move on and we're going to talk a little bit more about a force. So we're going to be learning about two important forces, and there are many others, but the two important forces that we're going to be learning about are, well, let's describe it. A force is a push or a pull on an object. Most forces are invisible, but you can see the result of the force. So the force is the cause, and we get to see the effect. Imagine standing in the middle of the classroom and throwing a ball up into the air, and then not doing anything else with that ball. What's going to happen to it? Can you imagine that? Trace that path the ball's going to take in your mind's eye. What happened? The ball that I imagined went up into the sky. Or into the air. I did not throw it hard enough to hit the ceiling. So it went up and it sort of stopped or paused for a moment, and it began coming back down. It hit the floor and it bounced a couple times until it just sort of rolled a little bit and stopped. I don't know if that's the imagination, the picture that you saw, the movie in your mind's eye. But the force of my arm in throwing and the invisible force that seems to pull the object back down to the ground are two of the forces that I observed. And the force of the ball stopping once it hit the ground. It didn't crash through the floor. So the reason an object thrown in the air comes back down to the ground is the same reason why Earth and other planets stay in orbit around the sun. And it's the same reason why all of the gas and dust of the stars that exist in galaxies doesn't just disappear farther into space. This invisible force is called gravity. So what if I threw a piece of paper, not wadded up like a ball, but just a plain piece of flat paper up into the air? Picture that. What would happen to that piece of paper? Would it travel like the ball did, or will it move differently? Well, that piece of paper is under the influence of another invisible force, friction. Friction is a force that resists or tries to stop motion. So gravity's pulling the paper down, and it still does, but does the paper come in a direct up and down motion like the ball did? No, it sort of floats and it twists, and it can end up farther away. This force of friction acts to slow down the motion of an object. So we will be listening today to find out about the force of gravity that will help keep planets in orbit around the sun. And we're going to sneak in some friction as well. Well, the last time we met, we talked about our amazing Milky Way galaxy. I still have the incredible image in my head, a swirling spiral of dust and gas and the light of billions of stars. It is gigantic. It's beautiful. It's amazing that we live in it. Here is where we live. This is our solar system right here. Our Milky Way galaxy is full of solar systems. The only ones that we've ever discovered and noticed are in the Milky Way. We have not discovered solar systems outside our Milky Way, I don't think yet. You can email me if I'm wrong. We live on a planet Earth, which is part of our neighborhood called the solar system. And the solar system has 8 planets that orbit the sun. And you remember how scientists classify the sun, right? The sun and the solar system are in a galaxy called the Milky Way. A galaxy is basically a vast cluster of celestial bodies in space that contain billions or hundreds of billions of stars, along with gas and dust. There are billions of galaxies beside the Milky Way in the universe. Each one has billions of stars in it. So what exactly holds all of this stuff together? in this huge universe? And why don't all the stars and planets just go flying off in any direction all over the universe? Why do they stick together in groups and clusters like solar systems and galaxies? Excellent questions. And the answer is gravity. Gravity is an invisible force of attraction between objects. Repeat. Gravity is an invisible force of attraction between objects. It's the force that holds galaxies and solar systems together. It's the force that keeps us firmly planted on planet Earth instead of flying off into space. It's the force that keeps Earth orbiting around the sun and keeps the moon orbiting around Earth. Doesn't gravity sound pretty powerful? It is, and it affects you and me all the time. We can't see it or touch it, but gravity is present between everything in the universe that has mass. Because of gravity, every single bit of matter in the universe pulls on every other piece of matter in the universe. You and I exert a pull on each other, but because we have very little mass in our bodies compared to celestial bodies, our gravitational pull on each other is very small. So small that we can't really even feel it at all. Gravity depends greatly on mass. So what exactly is mass? Mass is just the amount of matter in an object. You and I are small compared to, say, a planet or a star. We're made of less stuff, so our mass is much, much smaller. Mass is important when you're trying to understand gravity because the larger the mass, the larger the gravitational pull. So objects that with really large masses like stars and planets have a really big gravitational pull on other objects. And objects with really small masses like you or me have really small gravitational pulls on other objects, so small that we don't even really notice the pull at all. The more mass an object has, the more gravity or pull it is capable of. Because Earth has so much mass compared to all of the things that are on the surface of the Earth, its surface gravity keeps the things on Earth from flying off into space. You, your house, your bed, a ball you throw up in the air, all of these things stay on Earth due to gravity. Even the Earth's atmosphere and the oxygen we breathe are held close to Earth by its gravitational pull. Gravity also causes you to have weight when you stand on a scale. Gravity pulls you down. Earth's gravity pulls down on you. The more mass you have, the harder the pull and the higher the numbers on the scale. Think about an astronaut who's standing on the moon. The astronaut stays on the surface of the moon because of the moon's gravity. If the astronaut stood on a scale on the moon, though, the astronaut's weight would be about 6 times less than the weight of the same astronaut on a scale on Earth. So a person who weighs 60 pounds on Earth would only weigh about 10 pounds on the moon, about the weight of a bag of flour, because the moon has less mass than Earth, and its force of gravity is not as strong. That's why you maybe have seen images of astronauts sort of bouncing along as they walk on the moon. That's because the moon has less pull on their bodies, and when they walk, the weaker pull of the gravity changes the movements. It's like they're bouncing. The astronaut does not get pulled off of the moon and back through space to Earth, though. Earth still has a larger mass than the moon, and it still has a larger gravitational pull than the moon. But because the astronaut is far away from the Earth and very close to the moon, the gravitational pull of the moon has the most effect. It keeps the astronaut on the moon. That's the same reason we stay on Earth, and the moon stays in orbit around Earth. And we don't get pulled by the sun's gravity out into space toward the sun. It's another important thing to know about gravity. The distance between two objects affects the gravitational pull between them. Objects that are close to each other pull harder than objects that are farther away. The effect of an object's gravitational pull lessens as you get farther away from it. The sun has a lot more mass than Earth does, but the sun is also a lot farther away. And because we are on the surface of the Earth, Earth's gravity has a much bigger effect on us, keeping us firmly on Earth. That's a great benefit of gravity for us. The sun contains 99% of all the mass in our solar system. Because the sun has more mass by far than anything else in the solar system, it also has more gravity than anything else in the solar system. The sun's gravity, or force of attraction, is so strong that it constantly pulls all the planets toward it. Well, then you may be wondering why the planets don't crash into the sun if the sun is pulling on them. Don't worry, that never happens because the planets are also moving really fast in their own orbits around the sun. The combination of the planet's own speed and the sun's gravitational pull toward it is what keeps the planets constantly circling in orbit around the sun. It's a perfect balance. The planets continue in their predictable movements around the sun. Sometimes gravity is so powerful that a black hole is formed. An object or area with extremely strong gravitational pull. There are many black holes in space, and a black hole's gravity is so strong that once something gets close enough, nothing can escape its gravitational pull, not even light. Astronomers find black holes in space by noticing the movement of objects around them. You can't see gravity, but you can observe the way the force of gravity attracts objects. Like us, we can't see the wind, but we can see the effect of the wind. Scientists are still learning about black holes like many other things in outer space. On a clear night, we can often see the moon moving across our night sky. Have you ever been curious about why Earth has a moon? Well, many scientists think that it's about 4.5 billion years ago, there was a massive collision between Earth and a very large asteroid. The information they have gathered shows that the moon may have formed from the leftover debris from this amazing impact. Earth's gravity was able to hold the moon in its orbit. There's a strong gravitational pull between Earth and the moon. The moon's gravity pulls on everything on Earth, including people. But the Earth's gravity is still strong enough to keep us on Earth. Phew. The moon's gravity also pulls on Earth's oceans, but the Earth's gravity pulls back. And it's a good thing it's stronger. The moon's gravity is just strong enough that it can move the water on Earth enough to cause tides in the ocean. Tides cause the regular rise and fall of the ocean's water. People can see the effect of the tides if they're at the seashore. High tide is causing the waves to come up higher on the beach, and when low tide occurs, the waves don't come up as far. Low tide is a good time to walk on the beach and look for shells and the creatures that live in the sand. You remember, the moon orbits really around the Earth just like the Earth orbits around the sun. And whenever the oceans are close to the moon as it's orbiting, they get pulled. The gravity literally bunches up the oceans toward the moon. That pulls the oceans away from the shore, and you get a low tide. You'll also get a high tide when the oceans sort of relax because the moon's gravity is on the other side. It's pulling on the other side of the ocean, the other side of the water. So the waters relax and flow back up the beach. So interesting. So yes, the powerful effects of gravity can explain a lot of interesting things in the universe. It's what holds our moon in orbit around the Earth. It's what causes the ocean tides on Earth day after day after day. Gravity is why we stay on Earth and why objects we throw into the air come back down. Gravity even helps create new stars and planets by helping to pull together the gases and dust that form on them. We can't see gravity, but we can see its effects all around us on Earth, in our solar system, and throughout our galaxy. So gravity is an important force that exists in the universe. What is a force? A force is a push or a pull on any object. So what is gravity? Gravity is the force of attraction that pulls between two objects. Can you give an example that you heard in the read aloud about how gravity acts as a force? Well, objects falling back to Earth, the moon being held in Earth's orbit, the planets being held in the orbit by the sun, people and objects staying on the Earth, and the tides. What are two factors that affect how strong the gravity is between two objects? One factor is the mass of the object. The other factor is the distance between them. Mass and distance are the two factors that affect how strong gravity is between two objects. What's the main idea illustrated? I can't give this one to you because it's a different card, but there is a card that illustrates that the larger the mass, the more gravity it exerts upon an object. How are our everyday lives affected by the gravitational pull of the Earth? It keeps us planted on the ground. It keeps the atmosphere of Earth around our planet so that heat is trapped and we can breathe. It keeps people and objects from being thrown out into space. It causes the ocean tides. How are you affected by the gravitational pull of the sun? Sun's gravity holds Earth in its orbit around the sun. It keeps us at the right distance. Remember that Goldilocks sweet spot, ideal for life to exist. Why is there less gravity on some planets or celestial bodies than on others? Well, remember, gravity is affected by two things: the mass of the object and the distance between the two objects. So an object with less mass exerts less gravity on the surrounding objects. What happens when there's less gravity on a celestial body, such as the moon, than there is on Earth? Well, an object's going to weigh less. Gases may escape into space. Movement of humans, if we can get to that place where there's less gravity, might be different, like on the moon.